Hello everyone. I wanted to take just a minute to show you how to use the MolView molecular modeling software online. This is a really valuable tool to help with any kind of chemical visualization, but particularly in organic chemistry when you are trying to study stereochemistry and three-dimensional molecular structure. If you have a physical model kit, you can certainly build models that way and you can move them around. Um, so this is particularly helpful if you don't have a model kit, or if you're trying to build a large molecule that either will take too long to build, frankly, or that your model kit doesn't have enough pieces to build that model. So when you go to the website here, molview.org, you'll be prompted with this little speed bump. We'll close that. And you'll see here that the default is this molecule, and I'm not going to spoil the surprise and tell you what that is, but you could certainly look that up on your own if you wanted to. What you're going to do here is basically change or make a new drawing in the white panel using traditional drawing tools that you can see over here on the left, single bonds, double bonds, ring shapes, things like that. You have your atomic menu over here on the left. Depending on your screen configuration, you might see this as a side-by-side. So when I say top, it might actually be the left side of your screen. But I'll refer to this, this panel that I'm showing on the top as the drawing panel, and the panel I'm showing on the bottom as the modeling panel. So I'm going to hit the little trash can just to get rid of that starting molecule. And then you would draw something. So maybe I want to draw a molecule that looks like this. And I can move around, I can erase, I can use my forward and backward controls, I can undo and a redo button. So you're going to draw this. You can draw it in whatever configuration you like. For our purposes, since using this for stereochemistry is particularly useful, I'm going to put a stereo center in here, and maybe we'll make this a chlorine at that position. So notice how I'm using this. It's very similar to the drawing tools you will have used in other systems, whereby you draw the skeleton of the molecule. Everything that you're drawing is presumed to be a carbon with the accompanying hydrogens until you change something to a heteroatom, which is shown off here to the side. You can display the complete structure if you want to be sure that you're seeing everything where it should be by toggling this CH button at the in the menu bar at the top. All right, so we have this drawing, and obviously it doesn't match what's at the bottom. That's still the default drawing. So I'm going to click the 2D to 3D button, and we see the little progress bar across the top. It's rendering, and now I end up with this molecule. In that modeling window, I can drag this around and see what's going on, okay? And so I can move it around. It looks like this. I've got my chlorine on there. I can turn side to side by dragging horizontally. I can rotate up and down by dragging vertically. So the model, let me click this again. So you notice here that the particular structure that I drew says the resolved 3D structure can sometimes be inaccurate. And I wanted to do this in kind of on purpose because I wanted you to see the cases where you have to be careful, right? This is computerized technology. It's going to do the best that it can to understand what it is that you're trying to do. And when you read through this, I'm not going to read through all of this, but they tell us that sometimes in the cases of certain molecules, we can have a problem with the way it interprets things when not using explicit hydrogens. So when we look at my model that I drew here, right, we can see that this model shows my 1, 2, 3, 4, 5 carbons in a row with a chlorine coming towards the viewer on carbon 2. Now, when I look at the model down below, you'll notice here that it is not that molecule, right? If I orient it in the same direction with the carbon 1 on the left, I see that it was actually modeled with chlorine going away from the viewer, right? If I turn it a little, you can see that. So it actually modeled the wrong version. And before you say, well, that's not very helpful, you can avoid most of that most of those problems, oops, that's not what I meant, avoid most of those problems by simply putting in explicit hydrogens. All right, so if I do that and I model it again, we'll notice here, although it still gives me that warning, it wants me to know that I have to be careful. This is, in fact, the structure that I modeled. Okay, so like any other tool, you have to make sure that it's doing what you've asked it to do, and you have to verify that what you've drawn and what you've modeled there are correct. So now that I have the correct model at the bottom, I can zoom in on this. I'm using the scroll wheel on my mouse. I can turn this around, and we can clearly see that that chlorine is coming towards me. Now, where I think this is a really, really valuable tool is when you're trying to compare enantiomers. You're trying to compare molecules to see if they are, in fact, the same molecule or if they are a different view of a molecule that you've already drawn. So imagine for a moment that I was presented with a structure that looked like this. And to draw that in the upper window, I would be saying now the same basic molecule, 1, 2, 3, 4, 5 carbons. But now notice that my chlorine is here, pointed away from me. And just for the sake of completeness, I'm going to make sure I show my explicit hydrogen there. These two structures I've drawn on the top in the drawing window are identical molecules. And hopefully you can prove that to yourself with the modeling tool. If we look down at the bottom and we say, I know that this model came from the structure on the left where I had chlorine coming towards me when it would have looked like that. And now I can see by simply looking at it from a different vantage point, I get the structure that I drew second here, the one on the upper right. So these two are identical molecules, and if you can visualize it in your head by looking at the sort of skeletal structures up above, that's the kind of level of familiarity that you want to get to. You're building that up as you start to study these three-dimensional molecules. So if we were to look at these two, we would call them identical molecules. And so I'll put them over here next to each other. Those are identical molecules. What would their enantiomers look like? Well, that'd be a case of mirror imaging the stereocenter. And the easiest way to do that is to draw the skeletal structure in exactly the same way that you see it drawn. Okay, so just like that. And to either draw the bonds in the same places that they are like this, but to switch the positions of two of your substituents. Okay, that would be an enantiomer of the molecule drawn at the top. Or I could have reversed the positions of my groups. This is the other thing people might do, is to reverse the positions of my groups like this and draw them in the same place. Okay. Now, this one is actually the same molecule as up above. Remember that this is the wedge and the dash structures are meant to represent a three-dimensional reality on a two-dimensional paper. It does not matter whether I draw this dashed thing sort of up to the left or up to the right, because it's not really to the left or to the right. It's actually forward and backward. So don't fall into that trap. The easiest way for you to draw an enantiomer when you need to, if a homework question or something said, draw the enantiomer of the molecule shown in the top left. The absolute easiest way to do that is to draw your skeletal structure in exactly the same way, but switch, draw it in exactly the same way, but switch the, sorry, my drawing tools are getting out of control. Draw it in exactly the same way, like you did before, but switch the positions of the two of the groups, any two of the groups. But you can switch the positions like this. Now this molecule I drew on the bottom is the enantiomer of the molecules I drew in the first place. All right. If I wanted to prove that to myself, I could delete the other ones. I could model this. And what you're going to find now is that it would look exactly like this molecule, except the chlorine and hydrogen are reversed. That gives us a mirror image orientation on carbon number 2. All right. And so each of these would have the same name. These are both 2-chloropentanes, right? 1, 2, 3, 4, 5 carbons. Chlorine on carbon 2. They're both 2-chloropentanes, but they're enantiomers of each other. One of them would be the S2-chloropentane, and one would be R2-chloropentane. And that's a subject of a different discussion as far as Kahn-Ingold Prelog naming and numbering and assigning stereochemistry. But these two you would want to recognize as enantiomers, whereas the two on the top you would recognize as the same molecule. All right, so play around with the MolView program. There's lots more features than what I just showed you, but that's the basic of it. Draw your structure at the top, click the 2D to 3D modeling structure button, and you can see those different molecules. Now, the one thing that I do want to mention here, as I've modeled all 3 of these, it doesn't do a very good job of telling you which one is which. And so that's a little bit tricky. In that regard, I'm going to go ahead and delete the one that I know is identical and model them again. Now we can see I have 2 enantiomers that are mirror images of one another. Okay. So play around with this, practice, and check in again for another video. Good luck.